This video will walk you through the simulations that we did in Lesson 25, both the Monte Carlo simulation as well as the discrete event simulation. So last class we talked about how we could use parametric diagrams to quantify a TPM, in this case response time, as a function of some of the value parameters in the subcomponents through a parametric diagram. So loading up that parametric diagram, you can see right here that I have my response lookup time, my speech recognition time, and question processing time being added together to give me my response time, which is a function of my main block. So what I'm able to do next is I'm able to define these each as being a distribution. So let's start with RL time. I'm going to set it to be a uniform distribution with a value between 1.5 and 0.4. To apply the distribution, I go to Applied Stereotype, click on the three dots, and start typing in uniform. And you can see a property pops up right here. The D indicates it's a distribution. I'm going to check that. I'm going to hit Apply. And now if I scroll down, I can see my max and my min. Keep in mind that your max is first and then your min. So I'm going to set those values to be 1.5 and 0.4. And I'm going to hit Close. And you can see that it populates on the block. So I'm going to do the same with speech recognition time. But I'm going to use a normal distribution with a mean of 2 and a standard deviation of 1. So let's go for the same process. Normal distribution right here. Apply. Mean of 2, standard deviation of 1. Close. Layout, quick diagram layout. Now I'm going to do the same for question processing time, which I'm going to set as having a standard a normal distribution. With a mean of 1.5 and a standard deviation of 0.5. So you can see that it populates on the blocks here. And if I go back to my logical architecture, it pops up and populates on these blocks as well. All right, so now if I run my simulation for my block, I can see that I run it, it creates an instance. What it does is it pulls a number for each of those three variables based off those distributions I set. So 1.54, 1.06, 1.1, and you can see that those fit along with those distributions. Sums them together gets me 3.7 for my total response time, which is less than 3. So while it's useful to have that one single estimate, what you really want to do is you want to be able to run it multiple times. So I'm going to stop that simulation, close that, and I'm going to create a simulation that runs 1,000 times. So I'm going to go to Test Context and go to Create Diagram. And if I start typing in simulation, I can see that it gives me the option for a simulation configuration diagram. So I create that, and I'm just going to call this response time simulation. So first thing I have to do is indicate what I'm simulating. So in this case, it's going to be this Vista block right here. And let's go ahead and name this. I'm going to call this the Vista simulation. And then I also have to set the number of runs. I'm going to set it to be 1,000 runs. While it's great to be able to do it 1,000 times, it's not going to actually display anything that's useful or give you any sort of actual output unless you assign a user interface. And there's some options over here, and I'm going to use a histogram. So I'm going to drag that to the main screen here. I'm going to call this response time histogram. So I have to set it to be relative to the Vista block. And I have to set the parameter that's being used on the histogram. So I'm going to go with response time. I can just drag that from the containment tree. You can see it pops up right here. I'm now going to double click on here And where it says keep it open after termination, I'm going to change that to true. I'm going to change it dynamic to being true as well. What this allows us to do is it allows us to see the histogram change as the simulation is running. I'm going to hit close. And now I'm going to take my histogram. I'm going to drag it over on top of my simulation config window. And you can see that it pops up right here where it says UI, user interface, equals response time histogram. Now that I've defined the simulation, I can come up to this window up here. You can see Vista Simulation, Vista Simulation. I can just hit run. And my histogram pops up, and it's populating out. Right now, okay, we're at 1,000 runs, and there's a lot of good information on this histogram. So first off, the mean is 4.4467. The standard deviation is 1.1258. But what's really interesting is the requirement is that the response time has to be less than 3. So in that case, you can see that only a select number of the runs are less than 3, and it gives us a value over here in this over here where it says out of spec 0.8970. So we have our histogram, and it's a useful way to do a Monte Carlo simulation very quickly. And it's easier than a lot of the other software tools. And this is built right into your model. So you can mess around with your parameters and build out Monte Carlo simulations to do some useful analysis. So the next thing that we're going to do, just as a quick another example of doing a Monte Carlo simulation, is we're going to do the same thing for battery duration. I'm going to close this histogram, go back to my logical architecture. I'm going to close the simulation window just to have a little more space. And I'm going to change my battery life. Right now it's a point estimate. And I'm going to change it to being a uniform distribution between 20 and 28. So instead of going into the parametric diagram, I could actually just set it right here because everything's linked together. Go to specification, applied stereotype, make it uniform, apply, and set it as having a max of 28 and a min of 20. So you can see that populates right here, and everything's set. Now what I can do is I can go back to my simulation window and change my histogram. Instead of showing the response time, I can show battery life. Close. And because I'm already executing just the block, now it's just going to show the output for the battery life, which is also going to be changing as we go along. I already have my UI for response time histogram. Let's go ahead and execute it. And you can see my histogram for battery life. And because it's a uniform distribution between 20 and 28, it's relatively flat. There's a little bit of deviation across here. If I ran it 10,000 times, it'd be a little bit flatter. If I ran it 1,000,000 times, it'd be much flatter. But you can see that because the battery life has to be greater than 24, it's out of spec almost 50% of the time, which is about what you'd expect. So again, just another example of how to do a Monte Carlo simulation in Dassault System Architect. Next up, we're going to look at how to create a process flow diagram similar to what you do in ProModel. It's going to be fairly simplistic. However, once you know the basics, you can do a lot more with it. So I'm going to close my histogram, and I'm going to close the simulation window as well. I'm going to go to my behavioral model, internal behaviors, and go to create diagram. I'm going to create an activity diagram, and I'm going to call this process information. I'm now going to build out an activity diagram for the sequence of events that my simulation or that my Vista system would follow to be able to actually provide information back to the user. So convert audio signal to text, identify the question, query the onboard database, because there's an onboard database with it. If it's able to find the answer on the onboard database, the answer is going to follow different paths. So if it doesn't If it cannot find the answer, it's going to query the offboard database. So it's going to send a radio signal out to the cloud and try to get a response back. And then if it does have if there is an answer on the onboard database, then we can skip that offboard database question, and we can go ahead and move on to. Either way, you can move on from there to generating the response. Convert to audio response. And then I'm going to go ahead and end this activity. So what I need to do now is I need to set the guards to say when we follow this path versus going down that path. So to set the guard, I just double click on that arrow, and you can see it's right here. So I'm going to type in answer available on onboard database. I'm going to hit close. Now for this one, I'm just going to have it so that it's going to be else. So if the answer is available on the onboard database, it proceeds to generate the response. Otherwise, it goes into the offboard database, and then it continues on to generate the response. All right, so now suppose I wanted to actually go into a little more detail in this item right here, query offboard database. So what I'm going to do is I'm going to create a diagram of that, create an activity diagram. I'm going to put it in my internal behaviors, but I'm going to call it Ask the Cloud. And then it's going to follow a very simple sequence of activities. So it's going to encrypt the question, going to transmit question, it's going to receive a response. Keep in mind, there's more complicated ways to do this. I'm keeping it a little bit simple for right now. Decrypt transmission. And then we can end that activity. So I can hit this arrow up here to go back to my starting activity diagram. And you can see the fork that appears, which means there's a nested diagram inside that. So what I'm going to do next is I'm going to simulate my activity diagram. So I'm going to click anywhere on the canvas, right click, you can click on the general canvas area and go to run. You can see that it gives my activity diagram name right here. And I'm going to go ahead and hit start. So you can see that it's moving through. It hits that decision node and asks me that question of answer available on onboard database. So it's basically typing out the guard right there and asking me yes or no. If I hit yes, you can see it follows that arrow around and then terminates after it generates a response and converts to audio response. So let's run it again. But this time I'm going to say no. Nope. And you can see that it goes down that path instead. Now suppose we wanted to see the activities inside of there as well. What I could do is I can auto open diagrams. Click that button right there. Now I'm going to run it again. Hit no. All right, so it moved into that other activity diagram, and then it came back. So it's a good way to show, like, hey, what's the sequence of events that's happening, what's nested in what, and these simulations are very useful when trying to conceptually understand your system.